Welcome everyone. My name is Andrew Short. I'm an AWS Solutions Architect in Global Financial Services. My job is to work with large financial services customers, often like yourself, and help them achieve their goals in AWS. Before I started AWS, I was an application developer and support developer for capital markets firms, and I often supported applications that ran large databases behind the scenes, often relational databases, as their systems of record. In this 30-minute session, we're going to be talking about database modernization for financial services applications. So what's our agenda today? First, we'll walk through why application modernization matters. Why should you even care about it, and why does it matter to your clients? Oftentimes, there's one part of your stack that's really holding you back from achieving the benefits of modernization, and we'll talk about that. Then we'll go through tools and tips that AWS has in order to help you on this journey. So first, let's talk about the technical direction that we should look for when we're talking about modernization. As with all things technology, we should start for clues from our business and our clients. In this environment, there's really four big themes that we see from our customers. First is security. Cybersecurity has never been more important or a threat than it is today. Our institutions are built on trust, and that trust is paramount. This is something that we live through at AWS every day as well. Next is the ability to pivot fast. Speed matters in business, and the speed that you can adjust to rapidly changing market forces significantly impacts your ability to serve your customers. The COVID-19 pandemic has shown us this in spades. Market share is quickly gained or lost during periods of rapid change. Next, data has always been a central component of our applications, particularly when it comes to processing transactions. But now, our stakeholders and business leaders want data in order to make fast, rapid decisions and be able to see insights about their customers they didn't have before. Additionally, you can use AI/ML and big data tools in order to integrate analytics straight into your application and improve the user experience dramatically. Finally, clients, whether that's our retail or commercial clients, have high expectations for the digital services that we're able to provide for them. They hold us on bar with the leading technology companies, and they expect no less. Oftentimes, your user experience in your mobile app is more important than how many retail branch locations you have. And when you work with peer financial institutions, oftentimes you're looking at a REST API call instead of a batch file transfer. This is really hard for our industry, primarily because we've been around for so long. There's firms with decades or centuries of experience. They've built up technical debt and complexity over that time. But unfortunately, that doesn't let us off the hook with our client responsibilities. They have the same expectations for us, and they're all too eager to jump to new digital upstarts that don't have this same amount of technology baggage. But don't worry, AWS, we have some tools and tips that can help. So how have we adjusted to this new demand by our clients? Well, over time, we've changed the way that we architect applications. At a really simple level, we started with mainframes where the application and the database were converged into one component. We split it into client server. After client server, we went into service-oriented architecture, also known as like the three-tier application is a good example of that. Then the next iteration of the three-tier application is now microservices, where we're breaking apart components of the same app so they can independently scale and they can have the properties that are meaningful to that service. I know some of you are looking at this slide thinking you're probably further to the left than you are to the right, but that's okay. We can help you with that too. So there's one part of this stack that's really been holding us back, and that's relational databases. They end up being the Achilles heel of modernization. They haven't changed a lot over the last few decades, but despite their problems, they are at the center of many of our mission-critical applications. But unfortunately, they do have some major drawbacks. They're extremely complicated to scale and manage. It's not uncommon to take regular application outages in order to perform maintenance or apply patches. They're extremely expensive, both to purchase licensing for and to purchase reliable hardware. You often need to set them up in highly available and highly resilient in disaster recovery situations that requires you to purchase additional networking components and third-party products in order to make these things work properly. And then that doesn't even go into the amount of storage and backup appliances that you have to surround them with. It's difficult to switch databases. Many of these providers lock you into a proprietary language. It makes it very difficult to migrate and to be flexible amongst database engines. Monolithic databases, as they've come to be called, are very rigid and often slow down your application modernization by introducing dependencies that you didn't anticipate. An example we have here in the slide is multiple applications reading and writing to a single database. Let's assume one application is loading real-time prices. The other one is responsible for updating equity information, such as stock information. Another application might be serving a user interface and combining data from both sources. So this select statement would be from that application. It's selecting from both the symbols, which are stock tickers like AMZN for Amazon stock, and it's joining on the prices table. Now this is part of the schema of the relational database. If you wanted to do maintenance on this schema, or if one of the applications needed the way data is managed for it to change, it would have potentially significant impacts on all the other applications that also access that schema. This can hold us back from fully and truly modernizing our applications. To help us move past these issues, we've built a number of tools that you can use to help modernize your database and applications that rely on it. Our main approach is to provide developers choice and the right tool for the job. First, let's talk about the relational database category. We have Amazon RDS, which is essentially all of the databases that you've used for a long time, such as MySQL, PostgreSQL, SQL Server, or an Oracle. We offer those in a managed fashion. In addition to those, we have Amazon Aurora, which is Amazon's take on the relational database built with cloud-native features. We'll talk about that more in a minute. Next is Key Value Store, often called NoSQL databases. Amazon DynamoDB is Amazon's offering in this space. Amazon DynamoDB is extremely popular for key value operations that require extreme scale and performance. Just to give you an idea of the scale of Amazon DynamoDB, Amazon.com used it in its last Prime Day and peaked at over 45 million transactions per second. And that was just a fraction of what it handled that day. Next, for DocumentDB, JSON storage, we have Amazon DocumentDB, which is MongoDB compatible document store. For in-memory databases, Amazon Elasticache is managed Redis and Memcached. Amazon Neptune is a graph database, so you can map relationships between your data. Amazon TimeStream is a new timestream database that's built from its core to be able to handle time-oriented data. Time often was treated as just another field or column in your database table, but true time series operations require an optimized engine that knows how to sort and store that data, and that's what time series is. Amazon QLDB is an immutable, cryptographically verifiable transaction ledger where a central record of authority is critical. And finally, Amazon QSpaces is our fully managed Cassandra database offering. I know this seems like a lot, and there are a lot of choices in AWS, but when you start to work backwards from your customer, understand their requirements, and understand the needs of your application, it becomes clear which of these databases you should be using for a given use case. Let's keep going. So it's not lost on me how difficult migration can be. You're probably sitting there thinking to yourself, I get it, there's better options, but I'm so invested in my current database offering that there's no way I can move off of it in a reasonable time or in a reasonable amount of money. Well, we're trying to help with that. I've lived through that before, and I know it can be painful. So first, for the DDL components of your application, or of your database, like tables, views, indexes, we have the schema conversion tool. The schema conversion tool looks at your current database, analyzes where you want it to go, so the destination database. It provides you a report of how much of the DDL can be auto-converted to the new DBMS and how much you're going to have to manually convert. And over time, Amazon's worked to make that auto-conversion in order to maximize that. So you have to do the minimal amount of work as possible. For the actual data of your database, whether it's one-time or ongoing, you can use Amazon Data Migration Service. The data migration service provides asynchronous replication from your source database to your destination database. This also works even if they're not the same database engine. So if you're moving from Oracle to Aurora PostgreSQL, you can use both of these tools. Or if you're moving from like-to-like databases, like MySQL open source to Aurora MySQL, it also works in that case. We've used these tools to convert hundreds of thousands of databases, including our Amazon.com move from Oracle to Aurora and DynamoDB. So let's dive a little bit deeper into Amazon Aurora. Relational databases are proven to provide transactional integrity and performance for our core systems. But often, you have to trade off these benefits with the issues that we described earlier. Amazon decided to build its own relational database from the ground up, based on open source MySQL and PostgreSQL, but adding in all the enterprise reliability, performance, and cloud-native properties you expect. Aurora is fully managed. It handles patching, maintenance, deployments, backups, and scaling for you. It's completely compatible with MySQL and PostgreSQL in order to give you the most amount of flexibility. And simple pay-as-you-go pricing is exactly what you expect from the cloud. It's been extremely popular with financial services customers, and we're seeing people migrate to it every day. Some of those customers are here on the screen: NASDAQ, Capital One, FICO, and Intuit. So let's look a little bit deeper at Amazon Aurora and open the hood. So we've built a horizontally scaled distributed storage system that spans 3 availability zones for high availability. Essentially, we replicate your data 6 times across those 3 availability zones. The log-structured storage system, which is separate from the compute database nodes, allows independent scaling of both the storage and the compute components. That way, you can independently scale the storage without having to pay for additional database nodes. For Amazon Aurora, we automatically grow the storage in 10 gig chunks for you, and you only ever pay for the exact amount of storage that you need. For the compute nodes, we've optimized them beyond just what you get out of the box with PostgreSQL and MySQL. An example of that is if the database engine dies, the in-memory cache still maintains outside of the database process. That way, the database can restart, and when it's back online, it can have a warm cache to begin serving traffic. You can also spin up to 15 read replicas per region. So that means if you are experiencing heavy read volumes, you can spin up additional database replicas to immediately begin serving that read traffic. This is particularly useful when you have other applications that want to perform like OLAP style queries on top of your relational database, or if you have like a nightly batch job that's very read heavy, that's coming in at the same time as you're experiencing transactional workload. If you worked with relational databases before, you know that resource contention can be a really big problem, and it's very difficult to expand and go into a clustered type of setup. And Amazon Aurora is built intentionally in order to help you do this. In addition to within the region, Amazon Aurora Global Database allows you to do asynchronous replication to other regions. And then you can also read directly from those regions or promote those as part of your disaster recovery plan to primary databases if there's an issue in the primary region. For development and testing, Amazon Aurora also offers a serverless option. It's extremely easy and low cost to spin up a serverless database based on a snapshot of your primary database, and then it'll automatically grow and shrink based on the demands of your application and the amount of traffic that it receives. Aurora offers a truly modern development experience. Moving on to DynamoDB. When you're looking at new types of databases to use that weren't available decades ago, the first place you should start is in the NoSQL database, and Amazon DynamoDB is very popular with our customers. Amazon.com started to grow and scale earlier in its history. It ran into problems with the relational database. Sometimes this would result in hours of downtime. As an e-commerce site that made its money by being available, this wasn't acceptable. So these problems led to us eventually releasing the Dynamo white paper in 2007 and the release of the DynamoDB database. DynamoDB is serverless. It's built to handle the performance, size, and reliability of web scale applications. Automatically replicates across all 3 AZs in the region. It can dynamically scale based on the traffic that it's receiving. And a single DynamoDB table can handle trillions of objects. It's also been very popular with financial services customers, such as the one shown on the screen. So after going through these tools, it's time to talk about some of the best practices and tips your organization as you're on your modernization journey. Tip number 1. First, it's extremely difficult to modernize if you have to spend your time and resources on infrastructure. Your clients likely don't pay you to manage database hardware. Instead, they get value from your applications when you build your financial services expertise into them. Building enterprise-grade databases for your industry is extremely expensive and time-consuming. On top of the hardware and security requirements, you're setting up replication tools and monitoring, cross-data center links, large storage arrays and backup appliances, and configuring complicated clustered database solutions. You spend a lot of money and time doing these actions and not doing things that impact your business. Move up the stack. Have more of your developers and your money spent building features that your customers are asking for and not managing low-level hardware. Time spent on database maintenance, provisioning, and storage management is time not spent building better applications. Next, when we don't have to manage the infrastructure anymore, it means we can offer more choices. Stuffing all your hopes and dreams into one monolithic database leaves us exactly where we started, no matter what database we're using. By breaking apart the database monolith, you're giving applications more control of their data and removing dependencies. We've built all of these purpose-built databases, and they're all fully managed. So for each of your microservices, each of them can manage their data storage needs depending on the database that's appropriate for their use case. So if you look on the screen, we have an example from before where we have multiple different use cases, multiple different applications and services, all interacting with one database. And we've talked about how that can introduce dependencies. When the applications instead get to choose the database that's right for the job, they can take advantage of the qualities of that database and therefore serve their use case better and remove dependencies. And we'll talk more about that in the next slide. So tip number 3, and very important, enforce strong service boundaries when it comes to data access. Breaking applications into microservices can be risky for traditional relational databases. They can flood the connection pools and schema updates, get in the way of agility. Implementing a well-formed API access layer in front of your data services allows you a number of benefits. You can enforce more modern security access patterns instead of distributing database connection strings and users to people. Connection pooling, throttling, and error handling can be controlled gracefully and predictably by your API layer. Changes to the underlying database can be transparent to your users. You have the freedom of using one or more of the data sources and making changes at a faster pace. So let's now look back on the application that we originally had an example for. We have a real-time pricing application that's taking real-time prices and also updates to equity information such as AMZ and stock ticker. You have multiple applications that are reading from this database. What we've done here is instead of having direct access from the applications to the database, first we've removed it and put it behind a well-formed API. The well-formed API handles all of the throttling, security, access, and it's a well-documented interface in order for those applications to retrieve data from the database and the services that surround the database. Next, you'll see that we've separated the logic that's being used in the database. So where you would previously have like a SQL statement, we now have small services that are then backed by persistent databases that store the data. So first, let's look at the symbol, right? The symbol service is no longer just a table. The symbol service is actually business logic that whatever your application team needs in order to properly look up a symbol is self-contained within that service. And then the symbol service could decided to use a NoSQL database like DynamoDB because of the varying nature of stock data information. A database like a NoSQL database is a great choice because the schema doesn't have to be fixed. If equities and bonds have very different characteristics, and therefore you can actually have different schemas depending on whether the type of security instrument that you're storing in there or the data source that you're getting it for. If you're getting some of your equity information from one data source and some of your equity information from the other, you might have different column names and different numbers of columns. In a traditional model, you have to update your single table in order to adjust for that change. In our model, we're using DynamoDB, which is a NoSQL database, and it can handle varying schemas depending on which key value stores that you're storing. So the symbol service is receiving new symbols, symbol updates, and requests to get symbols data. The pricing service is receiving prices, both new prices, updates in prices, and requests for prices. These are kind of the low-level APIs of the service. Then the high-level API here is the consolidated lookup, right? So in our example earlier, we had a select statement. It was joining two tables together. One table had prices, the other had the symbol information, and that was all coming back to one application as one request. We can still implement that pattern, but instead of a complex SQL statement that's now embedded in your application, the application is calling an API that you understand. That API, the logic of that API is implemented by your team. You can control the access pattern. So the consolidated lookup is querying both the symbol service and the pricing service, getting that data back, and then returning it to the application and request it. So here we've used managed databases. We've put our services behind Wells Forms APIs. We've broken out from the single relational database model to a database that's fit for purpose. And we've broken apart our application to an architecture that we can continue to iterate on, we can build on, and when our business comes and demands new features, we'll be ready to react. So if you've enjoyed this talk and you've enjoyed hearing about all the different types of databases that we offer, particularly Aurora and Dynamo, I would encourage you to do more research. We have a lot of sessions going on both in this summit and from past summits available on YouTube. The AWS website has thorough documentation. The Dynamo white paper is released in 2007 and is a great read. In addition to these research items, we have a great training and certification program specifically for databases. The database learning path tells you how to get started, and then once you're ready, we have the AWS Certified Database Specialty Exam that you can take to represent your knowledge on AWS. Thank you so much for joining me. My name is Andrew Short. I'm a solutions architect in AWS Financial Services. I'd love to hear from you. My contact information is on the slide. Thanks for watching.